Good morning. Or whatever time it is for all of you.
Should we get started?
Yeah, I think so. Yeah, I think so. Did we have anybody volunteer to take notes yet? Oh, Spencer.
Nobody volunteered on the list, so I guess we'll have to force somebody to do it.
Mm-hmm.
Okay. Well done. Thank you.
Okay, thank you.
Anybody interested in volunteering for note taker? Ronnie, can we interest you? We do need a note taker to proceed, so.
You don't need all the blow by blow, just the,
It doesn't
action
have to.
items. No, Ronnie said he's on his phone, so.
Harold, are you willing to take notes?
I think I'll take the responsibility for the day.
Mo?
So you're raising your hand? Is that volunteering to?
I'm sorry, I have a hard time on some of my receive audio. I couldn't tell whether Harold said yes or no, but I would take notes, but just a warning, my receive audio is a little choppy, so you may just have to repeat a few things.
Oh, we'll take your offer, Mo.
Sure.
Thank you.
Okay.
This is Spencer. I can help when I'm not presenting, and I'm actually planning on talking a lot during the slot after mine as well. So, but I can help otherwise.
Thank you. Yeah, you please use the notes app, and it can multitask. So, great. So we will be managing a queue. Probably everyone knows how to use it by now. And you do need to enable your audio to be heard. You don't have to enable a video. You can if you like. Please keep both of them off unless you're chairing or presenting, and use of a handset or an echo canceling speakerphone is strongly recommended. Jonathan, do you want to go over the note well?
Yeah, so basically just as usual, if you have any IPR, you have to disclose it, and we are under or you have to disclose it subject to the policies. It's consult your lawyer for the details, and we are under various code of conduct. So please behave appropriately. I think that's more covered on the next slide. Indeed, yes. So we are under the code of conduct. So please behave professionally, and we, debate ideas, not people. If you feel like you have any problems, please either talk to your chairs or the ombuds team. Okay, as mentioned, our note takers are.
Yeah.
What did we say?
Spencer, oh,
Spencer and Mo, yes, indeed.
okay.
Thank you, Spencer and Mo.
So here's the agenda for today. We have more to go on the chair slides, covering the status, CFA, stuff like that. And then we have a presentation on green metadata, some things relating to RTP over quick, and then UN is going to talk about codec agnostic payload format. And then we'll have wrap-ups and next steps. Are there any agenda bashes? Okay. Want to do the draft status, Jonathan?
Yep. Okay. Yeah, we've had some things published. We have 2 things in Auth 48, so that's very cool. Those have their RFC numbers are assigned, so those should be popping out quite soon. Skip is an IETF last call, so we'll see what the comments on that are. Marketing, Mo, we do need a revised ID for that, so please. Let's see. I see you updated the slides at the very last minute. Yes, 7983 BIS has pub rec about an hour ago. So I'm sorry for that taking so long, but that's finally done. Did you update the slides at the last minute, Bernard?
Yeah.
Okay, cool. Thank you. I thought I was going to have to say this is and then let's see. Yeah, so then RTP over quick is adopted. EVC is adopted, but we need a revised. We need an updated draft. Stefan says he's juggling 2 calls, so I'll ask him in the chat. I don't know if that actually needs any changes.
Well, now that
I
BBC
think
is done, I think maybe they'll start from the BBC draft and.
Yeah, I think the idea there was to basically do the same thing as VVC. So yeah, so that's and then we need to have V3C republished as a working group document. I don't know if any of the authors of that are here today.
Lori, you're here.
Oh, Lori's here. Oh, Lori's here. Good.
Lori, you have anything you'd like to say?
Lori, I see you unmuted, but I don't hear you. So maybe you're having an issues with your audio.
Yeah, but Lucas has, maybe Lauri has problem with audio.
Okay.
Yeah, we can hear you now.
Yeah, this is Lucas.
No, we're hearing Lucas, huh?
So we submitted the document with the proper name, and the status is pending the approval from chairs.
Oh, okay, maybe we missed
Oh,
it.
we didn't. Okay, we will update that. Okay, and Stone says that they'll rep EVC as soon as EVC is published. I guess they want to make sure they base it on the final RFC editor
Final,
edits, which makes
yeah.
sense. Yeah, I
Okay,
don't want to have to
we'll
do that
go-
process more than once.
We'll go fish the B3C email out of our inboxes. and
Yeah.
approve it. Thanks.
Or I think Laurie published the link to the thing you need to click on, so let me look at that. It says pending approval by the chairs. Oh, okay. All right, I'll fish that out. We'll fish that out of the inbox.
Okay. Yeah, please note in a minute, there's an action item for the chairs to approve this. Thank you.
Okay, so green metadata, we had a call for adoption. There were some comments, people being in favor of it, and one thing with comment. So I think we have that on the agenda. So we can talk to that when we get to that.
Bernard, you said that the chairs had a action to approve something, but neither nor I caught exactly what.
Yeah, so it was yeah.
Go ahead.
Yeah, it was on the new draft for B3C. Approve it as a working group draft. So it was adopted and the authors submitted it, but somehow the approval, we didn't approve it. So we have an action item to do that.
Will do. Thank you.
So I think we're on the next slide.
Okay.
I guess Magnus isn't here.
Yeah. I guess, Yang, you're going to talk to these comments as well, right?
Yes. Hello, can you hear me?
Yes, we hear you.
Yeah, I have slides to respond to all those comments later.
Okay, great.
Thanks.
So can we skip some of this and then I guess cover it during your portion?
Right.
Okay.
Yeah, we'll get to that. Okay, here we are then. Okay.
All right. So I guess the question will be, have the comments been addressed and are we ready for adoption? I guess that's what we're trying to answer in Yang's presentation. Okay. Go ahead, Yang.
All right, thank you. So this is a presentation for the RTCP messages for green metadata. Next slide, please. So this just quick summary, the message we proposed. So the first is the request message, included the frame rate, picture width, picture height. And then the second message is the notification to respond to the frame rate, picture width and height in the notification message. Next slide, please. Yeah, we received a number of comments during the CFA. And the first comment is from Laura from Nokia. He comments that it is needed to clarify how adapting the bitstream of RTCP mechanism is used in collaboration with SDP update. We think that's a good comment, and we plan to add SDP definition subclause, similar the one as in the RFC 510 to define the RTCP feedback attribute and the relevant parameters for the proposed message. So the second comment that we received from Magnus is about the title. He feels the current title may not be clear because the green metadata is about energy saving, but the message, proposed message, does not provide any energy information. So he suggested to change it. So we think about like two titles for the group to consider. The first, we may change it to like RTCP messages for spatial and temporal resolutions. The second candidate title could be codec resolution control message in RTP audio visual profile with feedback. So yeah, we think the proposed message can be used beyond the green metadata. So we are open to change the title, but would like to hear from the group which title may be more appropriate. So I may stop here and see any comments.
I feel like it's probably best not to do too much of this bashing on the you know, in real time. Go ahead, Stefan. Stefan, I do not hear you. Possibly you're still having audio issues in the other direction. Anyway, I mean, obviously, I'm not sure doing the the details of bashing.
Yeah,
the,
Stefan has the on the chat.
Mm.
He wrote something on the chat. The green metadata, it's known now. So, should we keep?
Yeah, I guess. I mean, I guess the question is, I think that's probably well known in the ITU/ISO community, where that work is being done. I'm not sure how well it's known in the IETF community. So, yeah, I mean, I think, I feel like trying to do the details of bashing I think that would be better for the mailing list than live in the conference to figure out the details of what the title should be. So I'd say start a separate thread on that on the mailing list, and we can discuss it.
So should we change the title to or not?
I think the answer is we should discuss that on the mailing list, what the title should be, rather than trying to figure it out live in the meeting. Yeah, but yeah,
Okay.
I think, especially because Magnus isn't here. But yeah, I mean.
Yeah, please indicate that in the notes, Spencer and Mo.
Yeah.
All right. So let's move on to next comment. So next comment is that currently the notification message just repeats the picture width, height, and frame rate, and the comments that may be wasteful. So maybe only send the SSRC and the sequence number is enough. So in that case, we can save 132 bits per FCI entry, but that's the only one can be saved, because we still have to keep sending the SSRC and the sequence number. I checked the current or the existing notification. They just send all the complete field, so that the benefit to keep all three all the fields is to be consistent with the current design. But we are open if people think 32-bit saving is quite significant in this case.
Yeah, I feel like it's as an individual, my inclination would be to say better to be descriptive if it's not that expensive. And this also introduces the possibility of, like, you could send an unsolicited TSDN if you were just doing something unilaterally, which I think happens for some of the other messages. But I'm not sure if that's a good idea, but open.
Okay. So
yeah.
we
So
can.
yeah, I'd say leave. My inclination would be to leave that alone.
Okay.
Mhm.
Thanks. The last question is just the question that in case the media sender will change the resolution of frame rate or the spatial resolution due to the congestion, then it probably not will need to send any notification. Yeah, so that's maximum case, and I just confirm, yeah, that's true. If sender just change the resolution by itself, it does not have to send any notification.
Yeah. Yeah, this is analogous to how Timber works. Like, Timber is a max bit rate, but this is that's it should be clear. This is setting a maximum, and it can go underneath it for. It should be clear that that this is setting a cap, and not necessarily you can go underneath it for other reasons.
Right.
Okay.
All right. Next slide, please. Yeah. So we ask for the bridge adoption. So that conclude my presentation. Thanks.
Yeah, I mean, as I would say, yes, I think the issues that were raised are all things that can be done, addressed successfully during, the working group development of the draft. And I think that this is probably fine to be adopted. The possible, we should get possibly get consensus on the title, just because that probably the document. So we should probably figure out what we want that to be called before we decide what the draft IETF-AVTCORE document is going to be named. So let's have a discussion of that on the list, and then we can do the adoption.
So the conclusion for the minutes is to debate the title on the list, and then once the title is settled, to submit a working group draft with that title reflected in the name. And overall, the draft is adopted, but just have to figure out the title and the name of the draft. Okay, thank you.
Thank you.
Okay, this is the next topic. And to be clear, this is related to RTP over quick, and it's a subject that came up both in some experiments I've been doing and also came up on the mock list. So on the mock list, there was a posting from Christian Wiedema, who's also been implementing media over quick, and he discovered something which I think I've also seen, which is that it's possible in some circumstances for quick to run out of to hit what's called the max streams limit. And it depends on the use case, and also if the application is doing perhaps not cleaning up after itself correctly, leaving streams open. So a little bit more about it. So the question is this a potential issue with a quick or a web transport implementation? There do seem to be some use cases where a default max streams limit could be exceeded. We'll talk about that in a moment, like conferencing. I have filed an issue on the Web Transport API because at least currently there's no way for a client to set a max streams limit that might be higher than the default. So there's a potential API issue there. But I've done a few experiments, and if you're just sending a single RTP stream and you're cleaning up after yourself, closing streams after they're used, then you probably won't hit this limit unless for some reason your implementation has it very small. But I've encountered situations where if you don't clean up after yourself, you can leak resources, leave streams open for some reason, then you will hit it, and there's all kinds of bad things that happen, like the glass-to-glass delay goes very, very high. So one question is whether there's any text needed in the RTP over quick specification, just warning about this. I filed issue 49. So we'll talk about a little bit more whether it's something we actually need to address in the document or just be aware of for implementers. So a little bit about the frame per stream model. I think we know how it works, which is in the send pipeline, the sender opens the unidirectional stream. Perhaps if they want partial reliability, they'll set a timer. And if the timer fires, they reset the stream. Otherwise, they'll write the RTP header and the payload to the unidirectional stream and then close the stream. And on the receive side, receiver is notified of an incoming unidirectional stream, and they read from it until the stream is closed or it's reset. And sometimes a lane field is useful to know if it was completely received. Now, so I did a little experiment and with frame per stream transport. It turns out how this performs and whether you hit the limit depends a lot on what I would call concurrency. As you know, iframes are a lot larger than your average p-frame, sometimes as much as 10 times the size. And what concurrency means is that on the quick stream, you're sending the iframe at the same time as potentially multiple p-frames. At least in JavaScript, you have to be aware of blocking if you're doing that. And in particular, JavaScript await will block. So you have to get rid of that stuff if you want to make sure that you can do concurrent sending of iframes and p-frames. So it's a good sign if you see multiple p-frames arrive on the receiver prior to the complete receipt of the iframe, because the iframe is so much bigger. That's kind of what you'd expect if you were doing concurrent sending. So I've been going through my example implementation, just trying to eliminate all the awaits. And after doing that, you do see a lot of reordering, about 3 to 6 events per experiment, mostly in the initial iframe and p-frame, and a few other nice effects because the iframe is closer to the transmission line. Still need to do a little bit of work on the read pipeline, but the point is, if you're basically doing a good job on this, you will have concurrency, and that means you'll have a number of open streams open on a single RTP stream. Hopefully, let's talk about that a little bit more. So here's an example of what you see after you've optimized it a bit. This is a run with AV1 at full HD resolution, about 418 kilobits, average bit rate, 30 frames a second. GOP size about 3,000 frames between keyframes. So almost all p-frames with maybe one p-frame in an experiment with 3 temporal layers. So you can see the largest iframe here is about 12,590 octets. The p-frame is much smaller, a little bit bigger than the average packet at 1523. And with concurrency, the iframe is much closer to the transmission line. So essentially you have enough C-wind to send the iframe in a single C-wind. Okay. So overall, the question is this a problem? And for a single RTP stream, the answer is almost certainly no. I haven't, when I was doing this, I only saw a maximum of 5 concurrent open quick streams for a single SSRC, assuming you don't have a lot of loss. I guess if you have loss, you might end up with more. But I would note that I did hit the max stream limit once, and that was because there were issues closing streams and releasing all resources. So if you have leaks, then you could conceivably hit the limit, but if you're doing a good job, probably not. Now, as I mentioned, if you have loss, the limit could be higher. If you're doing priority, typically what people will do is they'll say, send the iframe and don't do concurrency with the p-frames. And so you'll end up with lower concurrent streams. But on the other hand, your glass-to-glass delay will be higher, so that might not be the best idea. The one situation in which it seems like you could hit the max streams limit is in conferencing. For example, people commonly do 7x7 grits or 49 simultaneous video streams, and there's continual demand for more. I've heard of people asking for 11x11. So in that kind of a circumstance, if you had, say, 5 simultaneous quick streams and then 50, video streams, you could end up with 250 or 500 or something max streams. Mo?
Yeah, just a clarification question. Maybe my confusion. I thought the max streams limit was just the numeric number of stream IDs, the maximum stream ID numeric value that it can be, not the number of actual concurrent open streams right now. So I didn't think there was any accounting that closed streams would somehow alter the max streams limit. I thought it was just a fixed limit that number, the stream ID can't go above that number. This suggests that the max streams is the number of active open concurrent streams. Is that right? Is that what?
That's my understanding, yes.
So we have different understandings. Does anybody that knows Quick really well, authoritatively, know what the right answer is? I'll double check if no one knows, but I thought it was not anything to do with open streams. It was just the max stream number that could be.
Yeah, you wouldn't want to just hit, 100 would be really, really low for the maximum number of streams you could ever open. Yeah, that would make no sense.
I'll take an action to check
Okay.
with the Quick authority on this, because I think that this would be a big turning point for stream per frame.
Our stream number,
I didn't quite catch you, Jonathan.
our stream number is reusable.
No.
No, they are not.
If you wrap, you have to reopen the connection.
Yeah, they're not reusable.
Yeah, they're not.
But I don't think there's an accounting of the number of closed streams to modify anything, to modify max streams or anything else. That's what I'll take an action to clarify.
Yeah, but what I've seen, Mo, is I've seen situations where I didn't close a stream or didn't release resources, and then I ran into a wall where the delay went crazy.
I fully believe there's some internal implementation accounting of max streams.
Right.
You'll have some internal state, and you'll have to search trees of active things, but not search trees of closed things. But
Right.
I didn't think that affects the max streams limit.
Okay. So anyway, there's also an interaction with priority in that priority can be used to limit the number of concurrent streams. But people talk about waiting for the iframe to be finished before sending any p frames. That's actually a little bit problematic because it reintroduces head of line blocking. So a little bit better is to allow kind of a finite number of p frames to be sent along with your iframe, but it probably shouldn't be infinite. In terms of what implementations do, at least in Chromium, it apportions bandwidth equally between the open streams. By default, that's another good reason not to leave streams open, to close them, because otherwise you'll kind of slow everybody down. And the issue of partial reliability is independent of priority. So if stuff is taking too long, you can always send a reset stream. You can always call a board or something and get rid of it. Anyway, I think we have a good action item is to look at this a little bit further. It strikes me it's not, it is probably something maybe worth a note in the RTP over quick spec. I don't know that it deserves any more than that, but just something to be aware of. Mathis?
Okay, I think this is me. Mathis, do you think this is me?
Yeah, that's what I wanted to say too.
Okay, cool. And I'm just finishing up one sentence in the notes real quick. And now I'm not taking notes anymore, so I'll let somebody else keep up. Could I get the next slide, please? Okay, never mind. So we talked a little bit and very rapidly and at the end of the session about whether we actually had an agreed scope for RTP over Quick during our session in London. And York and I agreed that it was a good thing for us to work on that, and we spent some time having a working session while we were still in London, and we wanted to talk about where we think we are on scoping, just level setting with the working group, and making sure that the RTP over quick and the corresponding SDP specification are going to do what the working group thinks is expecting them to do. So early discussions on RTP over quick started out small. This is going to be a drop-in replacement for RTP over UDP. That's an unrealistic idea for a variety of reasons that we talked about in previous sessions. We want to do the right thing with RTP over quick, and the proposed goal is to do enough for this to be useful, and the proposed non-goal is don't do everything that we can imagine. So for now, let's focus on what we know we will need now, and don't do more than what we know that we need now, but try not to break anything that we might need later. I'm going to be asking, does that sound about right so far on each slide? And this is a slide, so I wanted to give people a chance to talk about that. If anyone has something to say.
I think that's about right. I mean, I think it's more, more specifically, I think that, this is designed to be something comparatively simple as opposed to mock, which is sort of doing the re-architect the world to, for exactly what we want. So I think this is, don't overlap.
Yeah, I'm sorry. Yeah.
Sorry. Go ahead.
And it looks like Sam is going to correct at least me.
Okay, go ahead.
Can you hear me okay?
Yeah.
Fantastic. Yeah, Sam Hurst, BBC R&D. Not sure if this is going to be a correction. More with an understanding. I might be preempting what you're about to say on a later slide, but what exactly do you mean by enough for RTP over quick to be useful?
That is actually a hive mind groupthink statement. So basically, if people in the working group jump up and down and say you didn't do too much, or you didn't do enough, or you did too much, we'd like to know that before going in rather than coming out. So basically this presentation is intended to be a significant chunk of that discussion, although not all of it, and we'll talk about that during the presentation. Does that make sense?
Yeah, it does. My only input on that would be, I think the enough for it to be useful is to define some way of carrying RTP frames over quick, and then you can scope that on multicast is problematic. Maybe don't do that just yet.
Yeah,
my input on that one.
Yeah, dude, you're reading the issues and get up. Good job. If we slip to the next slide, this may also be helpful. I'm waiting for the next slide to pop up. In the 1980s, there was a discussion on the history of programming languages about some languages were like, I order a pizza with the toppings that I want. Things like APL and Pascal that were designed by one person for one person's use and then adopted. That sometimes we say we will order a pizza with the toppings we want. This was the COBOL committee and people like that, where you get everybody in a room and say, it's got to do at least this. And so some people order a pizza with all the toppings that anybody could ever want. And that was what the Share Committee on PL1 did, NPL and PL1 did. So fast forwarding to the 2020s discussion on RTP over quick, my goal is that we order a quick RTP pizza with only the toppings that we need. Next slide, please. And I apologize for anybody that's suddenly hungry in the middle of lunch. So the planned usage is, Bernard, are you in queue?
I'll be in queue, but just finish your slide.
You want me to finish? You're finished. Okay, so I'm finishing this slide.
Yeah, go ahead.
Okay, cool. So the planned usages that we know about, and we probably started out with the SIP VoIP environments that are currently using RTP. And that kind of led us into the land of a drop-in replacement for RTP over UDP. We've been talking about WebRTC environments that are currently using RTP. And but we've also been talking about web transport environments carrying real-time media. There's Metis has more about details about this in the next section. So let's defer discussion about whether that's a bad idea or a good idea for now to Metis's next slot. And but I think I wanted to make sure that we were not missing planned usages that somebody knew about now. So, like I say, it's not to say that these are the right usages. I'm just trying to make sure that we've got all the ones that people are thinking of. Bernard, I would start with you.
Yeah, I'd be interested if there are folks who've dealt with PBXs or handsets, but I haven't really seen any interest in this from that community. Like if you're thinking that RTP over QUIC would be used in a SIP trunk to a carrier, I haven't really seen interest in that, or in a handset or in a PBX. So I do think that's curious. With WebRTC, you know, there is some history of peer-to-peer QUIC that went through an origin trial, but there's no official W3C activity. So that one also seems kind of curious. So the first two, I'm not sure where people got the idea that there was interest there, but I'm not seeing it at least.
Excellent. So are you pointing us towards web transport as the planned usage?
Well, I will say that web transport is a planned usage. I'll let others comment on whether it's the planned
Yeah,
usage.
you're right. I was saying on this slide so far. And this is definitely something that would be, whoever is taking notes, it would be awesome to capture this as an action for the mailing list discussion. But just basically, especially the WebRTC one, but just asking that. I'm seeing people in like 3GPP SA4 who are wanting to do WebRTC for media, and in the same technical specification committee, they are doing other things with QUIC. So it's not that much of a leap for them, for me to imagine them being interested.
Yeah, I guess there is a little bit of a difference, Spencer. You have to be clear. There's WebRTC, and then there's the web, right? Right, and those could be different. Like they could be doing WebRTC stuff with the WebRTC API, and then they could be doing something else with the web, which like web transport or something. So you just have to be clear. Anyway, Peter probably has more comments on that.
Hi, Peter. I'm not quite hearing you yet. Are you hearing you?
I am not hearing Peter.
Peter, come back. You scared him off.
Okay. Now, do people hear me?
Yeah.
Yeah, we can hear you.
Okay. Yeah, I was going to comment. I feel like the one thing about SIP VoIP environments, there was, I forget all the details, but I think several IETFs back. Now we hear you, Peter. But
okay, I'll mute until you're done.
Okay. That there was, I know there was a thing that Jonathan Rosenberg brought to dispatch several IETFs back, talking about, the idea of having a SIP architecture that integrated better into the web model, which I think that was, there was some interest in having, and that would, I think, presumably use something like RTP over QUIC as its media plane, potentially. So I think that might be, I mean, I don't think that's not anybody who's actively working on it, but there's some interest in it potentially too.
Right.
Uh,
But
That was
my-
actually, yeah, you have to be clear though, but wasn't he proposing RTP over HTTP?
I thought
Um,
that it was something really close to that.
yeah, I
Yeah.
mean, I think, but that sort of predated web transport being designed, so it's possible.
Right.
So I think,
I mean, yes,
yeah.
that's the other thing. It was really early, and we spent a lot of time talking about how much of the web infrastructure was HTTP 1.1. So I think that's something to look back on.
Mhm.
If somebody wanted to add if somebody wanted to add an action item for me to chase that would be lovely. So got Jonathan, have I done you?
Yeah. Yes, you have.
Okay,
So let me take myself out of the queue.
cool.
Peter?
So Peter?
All right, you hear me now?
Yeah, absolutely.
Okay, so first, I think Bernard's right that you should probably just speak in terms of web environments. Right now, someone might use WebRTC, but then maybe want to integrate RTP over Quick. And that, as far as I know, could not be done with WebRTC unless extensions to it were made. But the only extensions I know of are kind of a bring your own transport, and in that case, it would be a web transport. So you might have a situation where WebRTC is emitting something that looks like packets, and then web transport actually carries them. But in terms of this slide and planned usages, I think you should just speak in terms of web clients. But web transport would have to be a part of that, I think. The other comment I have is that I think you're missing use case here, which is just, say, mobile applications that do real-time communication using RTP, and they might want to use Quick instead. Is that what the first bullet point is when you say VoIP environments?
I wouldn't characterize it as a VoIP environment, Peter.
Yeah, there are tons of mobile apps that do RTC that would
Right.
probably enjoy using RTP over Quick. So that seems like
Yeah.
it warrants its own bullet point.
Excellent. And we've added that as in the minutes as something for us to chase, right? It looks like someone is hopefully typing still in the minutes. Cool. Thank you, Peter. Stefan? I am not quite hearing Stefan.
Stefan, can you say something, or are you saying something?
You may have just cut on. I'm not sure. You just popped up, and anyway, Stefan, we are not hearing you yet. Stefan is planning violence on his computer in Zulip, and Stefan, I am going to be looking at the chat for this. If it's helpful for you to put a comment in there, I will definitely see that as well.
So Stefan did say something in the chat. Said +1 to Peter's point. Also, the slide is overly standard centric. Define applications, not the call control, etc. standards.
Cool, excellent, and thank you for your help with that. Thank you, Stefan. Anybody else? Cool. So,
Sorry. Stefan says further. I still want to drop in replacement for RTP over UDP without standardized call controls. This is what large segments of the industry are using. So,
I'm sorry.
Stefan said further, I still want a drop-in replacement for RTP over UDP without standardized call controls, as this is what large segments of the industry are using.
Okay, excellent, cool. Yeah. Zoom. So for topologies, We know that we can't support all the 76, 67 topologies because section 3.3 of that specification does point to multi-point using multicast, and Quick doesn't have multicast yet. So we know we want to support some of those topologies, but we haven't discussed which topologies in detail yet. The -01 version of the RTP over Quick specification describes supported RTP technologies in general terms. And the proposal was to analyze the rest of the unicast topologies. And I added issue 47 for this in GitHub. Is this about right? And Stefan, you may still be in queue from the last one, or last slide, or for this one. Okay, so Stephen is out of queue. Is anybody getting in queue? Oh, Roman.
Hi.
Good
Roman.
morning good morning / afternoon / evening.
Okay, so good morning, good afternoon, or good morning, rest of the morning. We should be very careful with topologies because there are a lot of topologies there which would unnecessarily limit stuff. Like, for instance, because we're going to end up with SFU relaying to RTP and all the other wonderful things, which if we implement, we seriously limit the functionality and implementation options which we have.
Right.
And for God's sake, let's stay away from multicast because this was.
Okay. Full disclosure. I added issue 52 about multicast, and I'm not presenting it now. And we will ignore that possibility for the foreseeable future.
Yes, because it seriously messed up RTP and can seriously limit what we can do with RTC over Quick. One thing which kept coming up in topology with RTP as an issue is that even if it's a peer-to-peer topology, because of the different negotiation glare, you have multiple streams going, basically multiple RTP streams going over the same pre-negotiated channel.
Okay.
And there was in traditional RTP, it's not always easy to demux them, like especially like for instance, if you have a DTLS SRTP,
right,
you end up, for instance, with two DTLS sessions going over the same 5-tuple, and that was always a problem. And some of the Quick parameter characteristics make it easier because you can just start new stream and demultiplex by that. But we might have some it's probably going to go into the SDP negotiation. Like we need to make sure that if we negotiated this over SDP, that we have a way of demuxing multiple streams in the process of renegotiation, and I don't think it's actually covered in the topology section right now. So that might be something to be.
Yes, agreed.
So that's all my comments.
Cool. Anybody else in queue on topologies?
Sorry, I didn't give myself a cue, but I think you should at least, mention them all. I suspect some of them will be mentioned for, we don't think this is important for this use case, but, at least being able to make that decision explicitly is probably a good idea.
Yeah, and so obviously, and well, okay, it's obvious to me. It may not be obvious to everybody because I could be wrong, but it's obvious to me that we may end up with a certain amount of text on this, and that certain amount of text on this may be longer than what's in the current draft, and that could appear that text could appear in the draft. It could appear in its own draft. It could appear in which might update 67, 7667, or it could end up in its own draft that's standalone if it turns out to be different enough from the things that have been done with RTP in the past. So I think the right answer now is to write down the text and then figure out what to do with it. If that sounds fair. And does that sound fair, Jonathan?
Yeah, I think that seems reasonable. You know, better
Cool.
to have something written down that we can argue about than to.
Excellent. So I think that may take us to the next slide. Relevant quick extensions. So datagrams is a quick extension that has been part of the RTP over quick plan basically forever, and -01 of the RTP over quick specification assumes that the use of datagrams. We have had conversations, but not a lot of conversations about the possibility of using quick timestamps, which is currently a individual draft targeting the quick working group to allow better loss detection and congestion control in some situations. So those are the two extensions that I think the AVT-Core community has spent the most time talking about, at least where I could hear them. Bernard, I see you in queue.
Yeah, so in the WebTrans working group, we had a conversation about quick timestamps. Specifically, the W3C came and said, hey, can we make this mandatory for web transport for the reasons that were discussed in AVT Core? The general response was, that many quick implementations don't support timestamps. So that wasn't recommended as an approach. I don't know if this working group will feel differently, that quick timestamps is so important that it has to be there. But in general, at least at the moment, it's not widely implemented by any means.
Yeah, well, I mean, I know that people implement individual drafts, but I mean, this hasn't been adopted by the working group yet. So
Right.
people who have not implemented it yet have a pretty plausible excuse for not having done so. But yeah, I like I say, and this is I'm asking these questions now before we do a whole lot of work with quick timestamps and then say, oh, never mind.
Yeah, I guess the question would be, do people feel it's that important that they, that it should have a normative language or not? But
yeah, and I agree, and I'm not trying to be the AVT Core whisperer, but I suspect that AVT Core would feel better about pursuing this if it is moving forward in the quick working group. Peter, hi.
Hi, I'm interested to see quick timestamps happen so that congestion control algorithms that need them can use them. Is there any summary of a status of how well this particular draft is going?
Spencer's recollection, without clicking on the data tracker, is it's been through something like 9 revisions, if I'm remembering the right draft. But I don't, I have not seen a call for adoption Does anyone, is anyone smarter about this than me? And I see Jorg popped up in the queue as I was asking a question. I don't know if Jorg had a thought about that or not. Oh, okay. I am seeing in Zulip, Jorg saying limited response at this point. And that's, like I say, I think it's just too early in the discussions about quick timestamps in detail for a lot of people to have really focused on that. So this could be we will add a issue, and at the appropriate time we would see if we can move it forward. Does that sound about right?
I'm trying to figure out if somebody can hear me, but apparently it works now.
We just accidentally heard you. Please continue.
But there's also an echo. Somebody needs to mute. Okay. Still echo.
I will mute until you quit talking.
Okay. Doesn't help. Anyway, so yeah, Christian was wondering whether he should be putting more cycles into this specification. And this is really weird with the echo. Let me just mute, not mute me, but oh, that doesn't work. Okay. So Christian was wondering how much support or how much interest there would be into solving this timestamp problem. There was limited response inside the quick working group, and so at least no enthusiasm that would make it that he would put effort into taking this further right away. Can probably be convinced otherwise, but what we heard so far here also pointed in the direction that not many people would be implementing this.
Yeah, and like I said, that all makes perfect sense. Could I ask the chairs if it's okay if we have an action for working group participants who are interested in the possibility of using quick timestamps for RTP over quick to focus on that and provide some feedback?
No, that sounds good. Yeah. You mean provide feedback to the quick working group or on the list? Or
you guys tell me. I mean, it could be that it's helpful for us to discuss it, like whether it would be useful, and if we can't convince ourselves that it would be useful, having some people spin Christian up before we decide we don't care, it doesn't seem friendly.
Yeah. I mean, I feel like it depends somewhat on what exactly the congestion control coupling model is, where, if we're expecting to get, tight congestion control coupling with the quick stack, then yes. If it's loose coupling and, you have to do your own, higher level congestion for low latency at
Right.
user level, which is not entirely clear to me yet either. So,
well, even if you do though, Jonathan, it's still sometimes useful to know the one-way delay as opposed to RTT, which you can measure in your app. So even if you're doing your own, it's something that I've, in doing my own experiments, I would love to be able to get, particularly in very asymmetric links like cable, cable internet, right? It's very asymmetric. So
yeah. So I think if I'm quoting the draft correctly, the issues are either it is asymmetric or the congestion on the ACT path is significantly higher. but and like I said, don't quote me on that. That's what I'm remembering. But like I say, for us to just get more experience with what we're doing without timestamps and then figure out how badly we need it would be one strategy going forward. Mo, were you on topic for this?
Yes, just wanted to agree with Peter that I'm also interested in this for congestion control improvements, and also for the same reasons that Bernard is interested in one-way delay. That often feeds back into both congestion control and some other decisions at the application level. So I would like to see this progress. For the notes, I wasn't clear what the action was. Is it an action for the chairs to ask something on the AVT core list, soliciting feedback, or is it an action for the authors, for Spencer to solicit something on the list?
For the chairs, could you express a thought?
Well, I had the same question as Mo. I mean, whatever you think would be useful, we're willing to do, but I wasn't clear.
Yeah. So my definition of useful is to talk about this, for people who think they will care about this, to talk about it on the AVT core list first. And so I think my only question was, do I send that email or do you guys?
Well, how about if you send it, Spencer?
Action for me, Mo. Perfect.
Thank you.
And thank you for asking for that clarification. Hi, Harold. How is your day?
It's a beautiful day, and or night at the moment. But I was wanted to add a thought about quick timestamps. That timestamps aren't strictly needed for congestion control, but they're awfully useful for figuring out what to send next.
Yes.
So if we get around to detangling this question of protect the internet against those evil bits, and what do we send next now that we know what we can send?
Right.
I think we're going to find that timestamps are extremely useful. But again, defining the timestamps is sometimes a hard job. First packet, last packet, assemble packets. Yeah.
Right. Yeah, I think
timers. It hurts.
Right. I think it makes perfect sense to me that people who have been doing H3 may not care, because they know what they're going to send next roughly, since this is reliable. But it's maybe more of an interesting question for us than it is people who've been doing H3.
Actually, people who are still the people who invented the 6 parallel HTTP GETs for the first browsers are probably still interested in what they can do in parallel and what they can do next.
Sure.
Complicated.
Yeah, cool. That gets us to Jonathan.
Yeah, so I think part of the question here also is, what do we expect? How much information do we expect the RTP layers getting from the quick stack? And if people talk about how useful quick timestamps are, I think presume that the whatever the application that's sending RTP actually gets to know them, which I think has implications for what information is getting passed and for what abstract API do we assume there. So I think that's also something that we're going to need to think about to some extent, and this also probably has implications also for the web transport discussions, because that's actually a explicit API being defined.
Yeah, exactly. Okay, cool. I think that cleared the queue. AVT profiles. And I apologize for my rant about this in London, but I don't rant very often. We've had proposals that have ranged from AVT-PF to whether you're adding whether you're going to be doing secure RTP or whether you're going to be using the extended RTCP feedback and things like that. And so we've had some proposals for full proto definition, and actually I'm leaving. No, but basically filling out the definitions for full, as full proto definitions that we would put in a specification. And that included the point Roman made a while back about if you are doing ICE and you get all your ICE candidates come back as TCP candidates, whether you want to proceed with that or try to do something else, because if you can't do ICE for UDP for quick to use, you probably can't do ICE for UDP for RTP to use. And then streams, datagrams, or both as attributes to limit the combinatorialness of the registration. And like I said, this is I'm not typing this now, but that's I think that's what I'm headed towards. The next time I do a revision of the SDP specification. Jonathan?
Yeah, so my only comment on the SDP and SPF on, you say it's for ease of relaying and forwarding to UDP RTP, but the problem is that once you talk about S at that layer, you talk about what that layer's keying looks like. And I don't think we're going to be able to gateway DTLS SRTP to quick, unless you want to tunnel DTLS over quick, which sounds terrible. And I don't think you want to use security descriptions because that's generally terrible. So I feel like I would say that the problem with the S's is you need to define what the keying looks like, which might mean exporting from quick, but I'm not sure how useful that is if you're relaying and forwarding. So I would say maybe don't.
So let me try another thing. Like I say, these are things that we have talked about in discussions in the past, but not in a huge amount of detail. One thing we said for relay and forwarding is it would be easier for us to write a BCP saying if you're doing RTP over quick and on one side and RTP over UDP on the other side, you need to do secure RTP over UDP on the other side. And rather than saying, oh, we're going to do double encryption so that what the middle box gets is something that it can forward using SRTP on the other side. So, like I say,
keying. So, and then if you have to find that, you don't. Yeah.
So I'm not telling you that we know how to do this. Like I say, I'm asking you.
I mean, I'd say. My suggestion would be how. Help us figure out how to do keying.
That would also be a fine way to get through this. Yes. Roman, thank you for that. Roman, what's up?
So I'm just was thinking about SAVP. I'm not sure this is like in the grand scheme of things, relaying DTLS over quick is that horrible. It's not ideal, but it's we're talking about like 3 or 4 extra packets during the session setup. So it will make it very easy to build essentially gateways which will run in front of the existing DTLS SRTP infrastructure and gateway to SRTP, or essentially SRTP over quick with bypass of, again, it's going to be double encrypted. We're going to end up with more overhead than we want, slightly more overhead, but it will work, and it will work very quickly for any sort of like prototyping or build up. So
Yeah,
I'm not
yeah,
sure.
right,
Yeah.
right. I think another thing that we're talking about here is conversations that will be good for us to have after we've looked more closely at topologies.
Yeah.
So
I
yeah.
Yeah, I mean, sorry, just to say, to respond to Roman, I feel like, yes, there probably are use cases for what you're essentially doing is tunneling a DTLS SRTP over quick, but I think that's mask. And I think the right answer there is, use a mask, UDP forwarding session. People are already talking about using mask for this effect. And I don't feel like that's a use case we need to just discuss here.
Certainly we don't need to discuss it without talking to the nice people in mask. Yeah,
Okay.
that makes perfect sense. Okay, cool. Anything else on this slide?
No.
Excellent. Quick congestion control. So we've had, again, a range of thoughts about what to do, how much to say about quick congestion control. And what I'm talking about here is, I think, the least visible approach to quick congestion control, which is to define an ALPN that's not H3. Currently in 01, it's RTP muck quick. That would avoid the most awkward aspects of nested RTP and H3 control loops. So basically, if you're not talking to an H3 endpoint, if you are not an H3 endpoint talking to another H3 endpoint, there are a lot of things that become clearer quickly. So again, with this proposal, that's relying on the endpoints that are doing, say, RTP mux quick to do something appropriate, whatever that is. And the 01 version of the draft references Scream and NATA as examples. Bernard, perhaps you're unclear?
Yeah, the ALPN issue really is distinct from congestion control. So I don't know that I would mix those two things, but I think the ALPN proposal you have is fine. But it's really not, doesn't relate to congestion control. That's a separate thing.
I think so. Allow me to misquote Lucas, but I believe that in discussions about this, probably in the quick working group, because it's been a while, he was saying that was the easiest way to make sure that the person you were talking to knew you were not doing HTTP 3. So
it distinguishes the use, that's fine,
Yeah.
but that doesn't necessarily, but the congestion control algorithm is an orthogonal thing. So, as an example.
Yeah, I would agree with that. I would agree with that, Bernard.
Yeah, so as an example, in web transfer, they've been talking about adding to the constructor some hint about the congestion control you want, but that doesn't affect the ALPN at all. It just affects what congestion control is implemented. Anyway, they're just to say they're orthogonal things.
Yeah, and I think that you're thinking that they're more orthogonal than I was. And the reason we're having these discussions is to give me something to think about. But the other thing was we've these proposals have extended all the way into saying, I want to tell you what the congestion control is going to be, and to define certain aspects of the congestion control, and that was what we were trying to talk ourselves out of. If there's a constructor that says do something that's reasonable for real-time media, that would be fine with me too. Rather than saying, oh well, it's got to be, this kind of bandwidth probing and stuff like that. Does that make sense? Yeah, Bernard? Okay. Peter?
I agree with Bernard that it would be sad if there were implementations that said, if AOPN is RTP mux quick, use real-time congestion control algorithm, else use not real-time congestion control algorithm. I think it'd be much better if we just had a bit somewhere. I would like real-time congestion control algorithm, and then we didn't have some case statement in implementations based on AOPN.
Mm-hmm. Cool. Thank you for that. Vinny?
I just want to say that I agree with European should not be able to congestion control. And the Cream and Nara is just an example. It doesn't mean that it's associated with
Vinny, I'm getting a certain amount of breakup on your audio. You want to try again, or put it in Zulip?
Zulip.
That's better.
So I put it in the Zulip. I'm getting echo.
Let me. I can mute me.
I was just saying we should not say that the preference is congestion control like SCADA, and these examples should not be considered.
For the chairs and for Mo, are you getting that?
It was sort of hard to hear, but I think she was agreeing that we shouldn't have the congestion control tied to the ALPN. But
Cool. Okay. Excellent. And thank you for that, Vinny. Is there anything else? We may move on to the next slide. If we finish all of those, then I've got issues as of last night for doing the mapping between quick feedback and what we might want to get out of extended RTCP feedback, and working out the details of quick connection interconnection, quick connection interaction with ICE. And so those are new issues in the GitHub, and I saw Bernard has put in a couple, and so people are also busily typing. So, but that's the way it looked to me, and I wanted to thank people a lot for this session. I know it was very helpful for me, and I hope it was for Jorg and Mattis as well. And with that, I think I have one more slide saying thank you for sharing your thoughts, and see you in Yokohama. Next.
That looks like Vinny said something in the chat. So the examples of data stream shouldn't be taken as options. Congestion control algorithms I think those are just the ones that we actually have published documents on, so we can cite as.
Yeah, exactly.
Yeah.
We
I
say
mean, maybe
something
also
generally.
we could also I think there's like the expired draft on GCC also, which we could potentially cite, because I think that's the one that,
right,
subject to evolution, that's the one that the browsers are actually using for WebRTC. But yeah, to cite all of those is probably.
Cool. Thank you. Over to you, Mattis.
Yeah, thanks. I only have one topic to talk about today. Next slide, please. Multiplexing. We wanted to talk about this in London already, but we didn't have enough time to discuss it really. And we already talked about this in the last interim meeting too, I think. But in that meeting, I didn't include web transport, so I thought it may be useful to discuss this again today. In the past discussions, we have talked about multiplexing kind of related to ALPN, because when we define an ALPN, we probably or maybe also have to define the multiplexing, or also the other way around. If we define some multiplexing, we may also already have a decision on ALPN. And we also discussed about how much needs to be defined in this document. And yeah, that kind of extends the scoping discussion from earlier. The main question we try to answer is how to multiplex RTP over QUIC with non-RTP streams and datagrams, where non-RTP streams and datagrams means like RTP streams and datagrams that carry another protocol that is not RTP or RTCP. The current draft defines a flow ID or session identifier to do this, but we are not sure how compatible this will be with other formats. And then depending on what multiplexing we use, this might have implications on RTP over QUIC, because we also want to try lightweight and independent as much as possible. But of course, we also want to build something that's usable by most of us, or all of us. Next slide. So to discuss multiplexing, to get everyone on the same page first, the easiest thing we could do is to say we just put RTP packets for one RTP session in one QUIC connection. And if you want to do multiple RTP sessions, open another QUIC connection. That is kind of easy and is similar to what we could do over UDP, where we could put different RTP sessions using different UDP ports and do the multiplexing on those ports. And then we would, similar to that, use QUIC connection IDs instead. But that's also maybe not the best thing we can do, because maybe we can use one QUIC connection for multiple sessions and maybe also even for other things. So the next point is to how can we do multiplexing with multiple RTP sessions in one QUIC connection. And these RTP packets can be encapsulated in streams or datagrams or both. And because we are using the stream per frame model that Bernard talked about earlier, we can't use the QUIC stream ID to do multiplexing, because one RTP session or stream represents a lot of different streams. And also the datagrams don't have any stream ID. Is there... so for that, we would use some sort of a session identifier. And as I said earlier, this is the one we currently have in the draft. That would also help us to do RTCP packets in the same QUIC connection. And these RTCP packets could then be multiplexed with RTP sessions or different RTP sessions. And then the last point, if we want to do multiplexing with other protocols, what we would do over UDP is, for example, using RFC 7983 BIS to multiplex these different protocols. That would probably be possible inside QUIC 2, but not necessarily the best thing to do, because maybe we don't even want all these protocols. And Jonathan is in the queue.
Yeah, so I think one of the use cases that a lot of people, I think, who were looking at doing, various media over QUIC type solutions are interested in is the use case where your call control and your media are sharing the same QUIC connection. And the use case here is for like when you're going to a load balancer, and got something that spreads out to a lot of backend systems, and it makes the problem of making sure that your call control and your media go to the same box on the backend much easier if they're actually going through the same QUIC connection. So I feel like looking at multiplex, finding something where we can multiplex actually our call control, whether that's something proprietary or SIP or whatever, with the media, is probably something we should look at as an important use case. I think that's been something a lot of people have been interested in looking at. And that's obviously not 7983 BIS. That's something else. So maybe if it's too hard, maybe we should say no. But I think that's certainly a use case people have been interested in, and we should think about how we want to, if that's possible.
Yeah, I think I would consider this part of the last point where we multiplex RTP sessions, RTCP with other protocols, and we're not sure which protocol that is, and it's not necessarily one of those that are listed below here. And that is also what we want to talk about on the next slides. You want to...
Yeah. Oh, I see Sam Hurst had a comment in the chat. Is that Sam? Something you want to say at the mic? I think it's an interesting point.
Yeah, I certainly can do. So H3 for unidirectional streams has a stream type. I was wondering if there was maybe more of a general applicability to multiplexing. So you could start a stream as just RTP over QUIC in the ALPN, but then there's a transport extension that says, I support some other frame type that allows you to negotiate adding a stream type in the front when you open a new stream, so you can identify which protocol this is actually for. I don't know if that would be potentially more helpful.
Maybe. I think it may become helpful if we go to the next slide. We have a couple of options which we would like to talk about. One of them is web transport. The second is some part of web transport. And the last one is something I talked about in the last interim meeting. And I think when I go through these different options, we will also talk about how to bring in other protocols like that. And maybe that would already be helpful. Is that okay?
Peter, did you have a comment?
Say that if we want to make a generic multiplexing system, I mean, that is what web transport is, so it'd be kind of reinventing it. So I'm glad to see that's the first bullet point on your slide here.
Okay, so the three options we have is web transport, which was brought up in the last meeting, or actually was brought up as some more generic multiplexing layer, which we could introduce between the QUIC connection and RTP, and web transport could be one instance of this. The second option is to use partial web transport, which would be kind of more generic, using our own abstraction layer in between to do multiplexing, but maybe reuse parts of web transport for that. And the last option, I will talk about it later on a dedicated slide, for only doing RTP and RTCP first, but try to be extensible in the future for other protocols. So let's start with web transport. On the next slide, yeah. So web transport defines a couple of transport features, properties, and requirements. These features and properties and requirements can be implemented by different instances of transport protocols below, and they are currently defined for HTTP2 and HTTP3. The features would be very much what we would like to use for RTP over QUIC. We would have different sessions, which could be mapped to RTP sessions, or multiple RTP sessions in one QUIC connection, or even multiple web transport sessions to have one for RTP and one for something else. Then web transport defines datagrams and uni and bidirectional streams, which is exactly what we're using in QUIC for RTP over QUIC. And the transport properties include some notes about different transport protocols implementing these features, because for HTTP2, we don't have, for example, unreliable datagrams. So the transport properties are, or some of them are optional, for example, unreliable data delivery. Aborting streams may result in retransmissions, which would be the case for HTTP2, which runs over TCP. And datagrams may also be retransmitted in that case. But for the web transport mapping to HTTP3, we would pretty much get exactly the features we have in QUIC. Then there are a couple of requirements. The two first of them are, I think they are clear. We don't need to talk about them much. I also already mentioned the multiple sessions, which we could use for multiplexing. So that would solve our multiplexing problem. But then there are also two things which I don't really know how to work around them, or what to do with them. First of them is that a client needs to be able to indicate an origin to the server. And the second is to be able to describe a server endpoint location using a URI. And I have some the questions about these points on the next slide. So Bernard, if you can wait one more slide, that would be nice. Or is it specific to this slide?
Just one thing is the way web transport sessions are used is they're typically used to delimit browser tabs. So you can't really use a web transport session to have multiple different RTP sessions within a single tab. You could use a separate quick connection for that, but I don't think that's what you want. So yeah, I think you're misinterpreting what a web transport session is.
Okay, I see. That's helpful.
Yeah, I mean, if it's a non-browser context, that could work, but within a browser, it wouldn't work.
So we would need another multiplexing inside that one web transport session for.
You're doing it within a browser, yes.
But would it be possible to have different sessions for different things, or do we need to have our own multiplexing on top of web transport then again?
Well, you could either just use bundle, in which case it wouldn't matter. Right, just throw everything there. But if you wanted to actually be able to do different RTP sessions within a web transport session, you'd need to have some kind of multiplexing for that.
So one browser
tab.
said,
you could just say, fine, you're basically bundling everything within a web transport session. Don't worry about it.
So you can't open you can't open more than one web transport session inside a single tab, just for using their delimitations.
You can open a different connection and potentially have it be pooled, right, and then end up with different sessions. But it's unpredictable. You don't know whether you can't really control it. Pooling is not easily controlled. It's something the browser decides, not your application.
Okay, I see.
Yeah, it's like HTTP pooling on a browser, right? You might use the same HTTP connection, but you can't. It's up to the browser to decide whether you get that or not.
Mm-hmm. Okay, then maybe to continue what questions we also had about web transport. So that's an important point, I think, that we still would need to define our multiplexing on top of that. Then additional things we noted is the two points I noted before. We don't really know what to do with a client origin in RTP over QUIC and server endpoint URI, because we don't really have these concepts. Maybe we just ignore them. I don't really know if it would be a problem for us. We just wanted to note this here.
You don't have to deal with either of these things in your spec. Basically, a way to think about the URI, it's like WebSockets. You need a URI destination to establish the connection.
Mm-hmm.
So, you don't need to worry about it. Just assume it gets established somehow, and then just run RTP over QUIC over it.
Well, so presumably if we define, the SDP spec would need to say how you put the URI in the SDP for it.
Right. Yeah. Potentially. Right there. It would go there, but not in RTP. Yeah.
Yeah.
Yeah. Okay. So we just wanted to note them down here for RTP. Then for SDP, we might need to do something else. And then the last point is probably the one which is most important about when we think about using web transport for multiplexing for RTP over QUIC, is that it would be defined for HTTP 2 and 3. And we were wondering whether it really makes sense to depend on web transport and HTTP 2 and 3 to get RTP over QUIC done. I think that's the most important question we would like to answer here, either now or after I show the other two options, maybe. The next slide. So one idea that came up recently in a discussion with Spencer and Jörg is that we could also reuse parts of web transport and avoid this dependency on HTTP. We could basically ignore what is not really relevant for us. But we are also not really sure if we can simply reference things from web transport without saying or depending on HTTP. And we were also wondering how much different is this from the current approach using flow IDs, because we would probably rebuild something similar to the sessions in web transport using our own abstraction layer, and that would probably look similar to what we are using with flow IDs already. And then the last option on the next slide, what I already presented in October, I think, is that we limit ourselves to RTP and RTCP for now. Keep using the flow identifier so we can have multiple RTP sessions and RTCP all in the same quick connection. Then register the ALPN for RTP quick because it's not multiplexing with anything else anymore. And then allow other documents that could be described or could be written in the future to specify new LPN tokens, which will also then have to specify the multiplexing between RTP over quick and other protocols. How that multiplexing looks like is hard to describe in our document now because we don't know which other protocols we would need. And new documents could, knowing which protocols to multiplex with RTP over quick, for example, reuse our flow identifier to assign different flow identifiers for different protocols or build some other kind of multiplexing between those. Yeah, that's are the three options we currently see, and would be happy to hear your opinions on these. Yeah, Benno.
Yeah, I don't understand what partial web transport is. Like when you say avoid a dependency on HTTP, kind of web transport is negotiated within HTTP 3. So, I mean, in your implementation, you don't need all of the HTTP 3 headers. So in that respect, you don't need a full HTTP 3 implementation to do web transport. So your implementation can largely avoid it. But the protocol spec is kind of enmeshed with HTTP 3. And you also don't want to create your own version of web transport so it can't communicate with the ones in browsers. It's largely a browser specific thing. So you want to maintain browser compatibility, I think, or it doesn't make a lot of sense.
Yeah, I think maybe partial web transport is a bad naming here. What we were thinking was, since web transport is doing sessions and multiplexing between different sessions, we can look at how it's being done in web transport, and I think it's using session IDs, and reference these parts from the spec, so we don't have to invent our own multiplexing, which we currently do with with our flow identifiers.
Okay, yeah, that makes some sense. But then it's not that different than just full web transport, right? It's just
yeah.
And if you don't want to do HTTP2, you don't really have to. I mean, the API allows you to say, I don't want to drop down to HTTP2. It has no, there's no point. Or you could decide for some reason that you want to do it. And then obviously you will get these weird effects with the datagrams, but presumably you're ready for it.
Yeah, I agree that HTTP2 is probably then optional for us anyway, because I mean, there's also RTP over TCP, and if you really want to do HTTP and you know what you're doing, then it's fine, but probably most of us would use HTTP3. And the question here is rather, how can we, or do we want to avoid this dependency on HTTP3? Does it have implications that we do want to avoid or not?
So speaking as an individual, my inclination would be to say, define sort of a raw single RTP session over quick and define web transport, and the web transport should be able to handle all the demux cases and all the browser cases, and the other one can handle the, well, I don't want that complexity, but don't sort of don't do anything else unless we feel like we understand there's a use case for it. But maybe there is a use case for it and I'm not seeing it.
So I think that would kind of be the second option, that we look at web transport, see what it is doing, and reuse what we are interested in, like the multiplexing, and try to make it such that we can use RTP over a raw quick connection, but that we can also use it over a web transport session.
Yeah, I think my point beyond that is don't define multiplexing other than web transport, because I feel like defining our own multiplexing is probably not useful in that case. I'd say so. It basically says, if you want multiplexing, then use web transport, and if you don't want web multiplexing, use raw RTP over quick.
But since Bernard mentioned this earlier, would that be enough, given that we can't have multiple, or can't decide which web transport sessions go into one quick connection?
I mean, I guess the question is, how much do people actually care?
Are you speaking, Mathis? We can't hear you.
I think Jonathan heard what I said.
Yeah, I heard what Mathis said. Yeah, I think the question is, how much do, I mean, I think like I said, you can't control whether two web transports go in the same quick. And I guess the question is, do
Jonathan,
you
are you speaking?
I am
Anyone
speaking.
speaking?
I think Bernard is last audio. Yeah, I think, like I said, I think, you know, I guess the question is, do you actually need the two RTP sessions or whatever to go over the same quick connection, as opposed to two shared quick connection, as opposed to two parallel quick connections? How much does that matter to you? And I guess this thing would be, you know, the load balancer thing. But given that web transport is designed for load balancer cases, it isn't guaranteeing that. Presumably, people will have solutions they understand for how to do that. You know.
Yeah, that would be good to know how what people think about this. But I think it might be useful to have multiple RTP sessions in one quick connection, even if it's just to make congestion control between them easier.
Yeah, but I mean, I guess I don't know. Bernard, can you hear us now?
Yeah, I was going to say one other thing, which is that keep in mind that web transport is client server versus, I think of RTP over quick as being a peer-to-peer thing where you do peer-to-peer quick over ICE. So they are a little bit different. And requiring web transport and all that machinery might not, there's a lot of machinery in web transport which isn't necessary for peer-to-peer quick, like the client IDs and stuff like that. You don't really need that.
And
so
doesn't
just
and possibly doesn't even make sense if you.
Right.
Yeah. Mm-hmm.
Yeah. I think what we need to do is to give UN a little time. We probably need to move to his slides.
Yeah, I was just thinking that.
But the question is, how do we move forward on some of these questions? There's something we should note for the minutes.
I would say we don't yet have consensus. It probably makes sense for the authors to move forward on defining the various things, and maybe like as you get more into the details, you'll decide, hey, this is really hard, or hey, this is really easy, and you know that might give us more information.
Just a question from the chairs. Would it make sense to schedule another interim where we could get into this more?
I think it would be helpful for me to have more input on this, what is wanted by the working group. I'm not sure if we need an interim for that, or if we should start a mailing list thread for that.
Well, let's start a mailing list thread and see how it goes. And then
Yeah. Good. Okay, please note that in the minutes. That's the next step.
All right. Thanks.
Okay. UN, finally. Yeah. Maybe we can go a little bit over time, but anyway, go ahead, UN.
Can you hear me? Yeah.
We have.
Yes.
Yeah, I'll try to do it quick, maybe over quick. We'll see. Next slide. So this presentation is actually stemming from a side meeting that that was organized during the last IETF meeting. And the goal was to look at S-frame and RTP packetization. And generally speaking, the goal in that area is to enable end-to-end encryption of media over RTP. And I think in that meeting, Bernard, you mentioned SKIP, which is solving basically that. So SKIP is defining a payload format, also media subtypes, to allow encrypted content over RTP. It's really in the focus of a SKIP session, so it's not really applicable here. But yeah, the idea is to do the same as what was done for SKIP, but with a different scope. And the scope is WebRTC. And there the slide is slightly misleading because we're not trying to solve end-to-end encryption of media over RTP. We're just trying to solve it in the context of WebRTC, where there are some WebRTC clients and SFUs in the middle. And so during that meeting, it was thought good to define an architecture of WebRTC clients, SFUs, and so on, how they would interact with and try to solve the end-to-end encryption thing, so that we can identify requirements and also maybe provide hints at how we could do it. So that's what we started doing in the draft, the encrypted media RTP architecture document. So you can click on the link. It's on GitHub, so you can provide comments, PRs, or file issues as well, if you have some time. So next slide. So WebRTC. So we have like 3 main nodes usually. We have senders, which will be WebRTC clients, usually browsers. Then we have SFUs that will do the packet forwarding thing. And then receivers, which might also be web browsers. The typical architecture, and it's no different than generic RTP, is the packetizer is generating packets from metadata and the encoded frame content. And basically, whenever intermediaries need to get information of what the encoded frame is and so on, it can just reparse the encoded frame content because it's in the packet payloads, and then do processing based on that. In our case, where content is encrypted end-to-end, the packetizer cannot really extract information from the encoded frame content because it's encrypted. So this content is really opaque. And the same issues happens for intermediaries. They cannot extract information from the content. So it has to be replaced somehow by providing more encoded frame metadata to these intermediaries. So in the architecture, the encryptor is between the encoder and the packetizer. Next slide. So yeah, traditionally, the packetizer is tied with the encoder. But now we have the encryptor that is in between. And we think that now it kind of makes sense for the packetizer to become tied to the media encryptor. And the document is trying to define the relationship between the two and try to define some kind of interfaces between the encryptor and the packetizer. Ideally, because we are in WebRTC territory, small changes to the media encryptor should not require a new packetizer. We want to define enough requirements on the media encryptor, on the packetizer, so that whether you use S-frame format, V1, or pre-S-frame format, or even S-packet, basically the architecture remains the same, and the packetizer could be roughly the same. So since we are in WebRTC territory, we can, and since we want to define some kind of interfaces, we have web codecs. And web codecs is a web API that is defining interfaces for media decoders and encoders. And it's a really nice abstraction that we can use to model encryptor packetizer relationship. So next slide will focus on video because, yeah, video is a bit more difficult as well since there are more packetization being done. So on the media encryptor side, it must provide to the packetizer content metadata that is useful to intermediaries. And this content metadata is coming from either the media source or the media encoder. So for instance, video frame members. So video frame is representing a video frame in web codecs, and it has some members like color space, orientation. And all of this is metadata that the media encryptor would pass through to the packetizer. There's also some metadata related to the encoded video chunk, like the codec type, the frame type, the timestamp, the decoder config, the SVC metadata, and so on. So it's another bunch of metadata that is that the media encryptor could share with the media packetizer. And finally, the media encryptor is generating encrypted content. It will not provide the encoded content to the packetizer. It will instead provide the encrypted content. And from that, the media packetizer must do its job of generating packets. And the idea here is that since it has a lot of content metadata, it can generate RTP headers like CVO from video frame orientation and so on. And it can also generate RTP payloads, but this time it cannot analyze the content because it's encrypted. So it needs to do some splitting. It can be based on MTU, or it can be based on some other information provided by the media encryptor. We are thinking also that the media packetizer must transmit and generate the underlying payload type, so that is given as part of encoded video chunk, which represents the codec being used before encryption. Next slide. So that's working pretty well in the context of a video codec that is not doing SVC. Now with SVC, it's a bit different because now you're no longer caring about a video frame, but you will care about even individually decodable units that together will form will allow you to decode a video frame. And since we are in WebRTC territory where the SFU might want to send some decodable units to some clients and some other decodable units to some other clients, it's up to the media encryptor to get the decodable units and to encrypt them separately. And then it can provide to the packetizer the encrypted decodable unit content, and plus the metadata that is identifying what the decodable unit is. So it's not only the metadata related to the video frame, but also the metadata that is identifying the decodable unit. And again there, the packetizer will need to transmit this additional metadata. The good thing is that there we have an interface as well that is available in the slides, so you can see the frame number and so on. And WebCodex is providing that. So we already have an interface, an abstraction that we can use to clearly define the boundary between, and the contract between the encryptor and the packetizer. Next slide. Going now to packet forwarding unit. So the packet forwarding unit is receiving packets sent by the sender and will send some of them to other clients. And when it receives a packet, it needs to be able to compute to which decodable unit the packet is belonging to. And for that, we are thinking that the underlying codec type is really useful, as well as the marker bit and timestamp. And to actually decide whether this RTP packet needs to be forwarded or not, that's where the decodable unit metadata is really important. And one possibility here is to put that metadata in the dependency descriptor. And one additional potential requirement is that some SFUs might want to record the call, and they might want to record the encrypted content. So it should be feasible for an SFU to get back from the packets the actual encrypted content and store it somewhere, and then send it later on if need be. Going very quickly to the receiver side architecture now. Next slide. So now we are at the level of the end recipient. So the WebRTC client, it has the keys, so it can decrypt, but still before that, it's receiving packets. And it has very similar requirements as the packet forwarding unit, because it needs to reconstruct the encrypted content, but it also needs to do early processing on the packets. Like if it sees that it needs a keyframe, then send a fear and so on. And it also needs to be able to use existing RTP-based redundancy mechanisms. Yep, next slide. We're slightly over time, I guess it's fine. So basically, the document is defining the architecture and some API contracts that we could set for the different breaks of the pipeline. And we are thinking that there is a proof of feasibility of the overall implementation in the WebRTC world. Basically, you apply S-frame on each encoded video chunk. S-frame would be a pass-through to all the related metadata that is received from web codecs. And the RTP packetizer would generate the dependency descriptor RTP header extension from the metadata, and it will encrypt the content. It will split the encrypted content based on MTU. And the payload type itself could be prepended in the payload, for instance. We could think of, which is very similar to what Skip has done, adding some subtypes like audio encrypted or video encrypted, for instance, and use that for negotiation. Next slide, and I will be close to the end. So Peter mentioned that SFUs might want to repacketize, and that's something that is interesting. It's not really in the draft now, and that's something that I think we would welcome feedback there. Since there might be different MTUs or there might be different protocols, maybe some packets need to be split or merged. And I wonder whether it should be in scope of this work, and whether there are some cases that are more important, like large to small, for instance, might be more important than small to large or so on. So I'm not sure we will have a lot of time to discuss this, but yeah, feedback is welcome, either here or in the mailing list or on GitHub. And the last slide. So my temporary conclusion is that in the context of WebRTC, we can, it's desired to support end-to-end encrypted content, and we can actually do that. And it can be done even though the particularly encrypted format changes, like it can be S-frame, S-packet, it can be something else. We can still define the same architecture and hopefully reuse very, very similar packetizers. So the current architecture provides a basis for what and how we want to support packetization for encrypted content. It's still a draft, so I'm wondering whether at some point we want to submit it to the working group, or whether we should think of starting solutions instead. So thoughts from the working group. I only have like a few minutes left because I need to jump in some of the meetings, but if you have feedback, it's most welcome.
Harold. Yes, Jonathan first and then Harold.
Oh, I'm not sure I meant to raise my hand. I'm sorry. Go ahead, Harold.
Just say that I'm also working on this area, in this area, for other reasons. The handling of encoded media without having to decode it in order to understand what to do with it is quite important in a couple of scenarios we have looked at. I mean, end-to-end encrypted content is one important point, but I think we need an architecture for doing a little more than that. But this is also being discussed in WebRTC working group in WGC. So we should cooperate.
Yeah.
Peter?
If it wasn't already obvious, I'm in support of doing this and starting defining.
So what would be the next steps then, Bernard, Jonathan? Should I try to finalize the document and try to submit it, or should we focus more on solutions?
I think having the architecture just sort of as the background for things is useful. I'd say, you know, maybe submit that as a draft. I mean, submit it, you know, it doesn't have to be complete, but just, you know, as a 0.0 individual draft. It doesn't have to be perfect, obviously, but I'd say, but probably also start working on solutions in parallel, just so we can sort of see, okay, what do you have in mind, and how are you thinking of doing it? Just, you know, again, sort of, you know, broad outlines, you know, with some straw mans if need be, just so we can start having a place to start working on it. But I think there is a lot of interest in this. So I think it would certainly be something that the working group is interested in doing, sort of as a problem to solve.
Yeah, and I want to thank you, UN, also for progressing this. I know there's a bunch of things that you've done that are new, and I think represent progress from where we were.
Mm-hmm.
So I just want to encourage you to keep at it.
Okay, I'll try to submit it before the next IETF meeting. And I guess maybe with Peter and maybe Sergio as well, we might want to advance solutions then in the scope of this architecture draft and WebRTC.
Seems good. And, you know, like I said, if Harold said, if the, you know, W3C groups are working on it, make sure to coordinate with them as much as possible.
Yeah,
I mean, I'm
yeah,
sure
good point. I will. Yep. So maybe, Harold, I will put you in the loop as well.
Okay. I don't know, Peter, if you want to go over any of the remaining slides. You had, I think, 2 slides.
Yeah, just skip to the next one and I'll do it in like 2 minutes. Basically, if we're going to have a solution, I think we're trying to decide what to go into that. And as far as I know, there are 3 things that could go in. The biggest one is the payload type, but because including that helps avoid associated payload type explosion. And then within that, we can decide if it's optional or required, because there might be cases where you only have 1 audio codec. What's the point of burning a byte? But then there are other things like frame number or offset or index that are really just helpful for repacketization by an SFU for out of order packets. And this is something that Ewan talked about briefly. I don't think we have time to go into why those are useful, but I just wanted to point out that a major design decision is really just what is included in the format that we come up with, and you know, things can be optional.
Okay.
And this might be something where just having like a quick and dirty, you know, like you know, proof of concept implementation, just to play with it and see how hard is this implementation, how much do I actually use this information in my implementation will be useful. So just like toss something together in JavaScript or something.
Yeah.
Point. Maybe I could make a like big to smaller repacketization example.
Exactly. Yeah. Yeah.
Okay. I think we've reached the end of the meeting. I wanted to thank everybody for coming. And I guess we will, as mentioned, discuss a bunch of things on the mailing list, and also we will, of course, have our normal meeting at IETF 116.
Thank you all.
Thanks, everybody.
See you. Bye-bye.